brief overview. So with elasticity, we're talking about how sensitive consumers are to price changes. If we draw a very steep demand curve, we're saying that the quantity change is not going to be very much, right, given a certain price change. But if the demand curve is very flat, then we would get a very large change in the price. But in this chapter, you'll learn that you can calculate elasticity along a demand curve. Okay, so there's a certain calculation for it. Let me just see. Anyway, yeah, at some point we will. So elasticity in general is just the percentage change in the quantity over the percentage change in the price. Okay, this is very simple, it's just a ratio. If you have a 10% change in the price and that causes the quantity demanded to change by, say, 20%, then you would say that demand is elastic. When we calculate the percentage change, we don't do it the normal way. We divide it by the average. So for the percentage change, we look at the change in Q and then divide it by what the average is. So that's talked about in the lecture. But some of the main concepts are, one, that steeper demand curves represent consumers who are not sensitive to the price. So something like cigarettes. An elastic demand curve represents people or consumers that are very sensitive to the price. And usually when we have flat demand curves like this, we're talking about a good that's easy to substitute or easy to do without. But if we're thinking of goods like cigarettes or maybe just gasoline in general for your car, they're very difficult to substitute or do without. And so we would draw a very steep demand curve. And along the demand curve, though, we can calculate the percentage change, this elasticity coefficient, which gives us the responsiveness. And that actually changes along a demand curve. And it's related to revenue as well. So any linear demand curve in the center represents the most amount of revenue or expenditures on the good. And then this happens to correspond to the center of the demand curve. And so you'll see that this portion here is elastic because that ratio will be greater than 1. And here it will be inelastic because that ratio will be less than 1. So those are the main sort of concepts. That's for demand. And then there's also supply as well. Okay. And then there's also a couple others. So we look at the responsiveness of consumers to changes in prices. You also look at the responsiveness of firms with respect to changes in prices. So you can think of, suppose there's an increase in the price, how do firms respond to that in terms of how much they offer for sale? If there's a lot of obstacles for them to be able to increase their production, then supply is more inelastic. But if they can easily, boost their production and offer more for sale, then it's more elastic. And that there's a time element to that, because usually the shorter the period of time, the more obstacles there are. And then over time, those obstacles can be overcome.
In this example, we're going to look at an elastic. Well, we're going to be thinking about the elastic portion of a demand curve. So here we have the demand curve for hot dogs, and we have that we're going to decrease the price by 40%. Okay, so we're going to go from $5 to $3. So we're going from $5 to $3. So if the price of hot dogs is $5, the quantity demanded is 500. If we lower the price to $3, then that's going to increase our quantity demanded to 1,500. So in this case, we have that, what we're going to do is think about the total revenue and how that's changed. Well, when we had the price at $5, we were able to sell 500. Okay. So in this case, what is the revenue? Well, the revenue is going to be 5 times 500. And that's going to be the area of this rectangle here, which is A plus B. Okay. Now, if we lower the price to $3, okay, we're going to lose out on this revenue here, right? Because, where we started out, we were selling 500. But now for that initial 500, we're going to only be getting $3 rather than $5. So we're going to lose out on this, but we're going to gain this area C, because now we're going to be selling 1,000 more hot dogs. Although the price is lower, we've increased the amount we're going to sell. So we're going to gain this area here. So in this case, let's think about the elasticity here. Is this, elastic demand or inelastic demand? Well, we need to think about the percentage changes. So here we have a 40% decrease in the price of hot dogs, but we have a 200% increase in sales. We go from 500 to 1,500. So when the percentage change in the quantity demanded is greater than the percentage change in the price, we say that the demand is elastic. And when it's elastic, we will see that the revenue will increase. Intuitively, the amount of sales we'll gain, the extra amount of sales we'll gain from lowering the price will give us more revenue. That extra revenue will offset the lower revenue as a result of charging a lower price. Now, in the next example, we have the opposite case. So here we have a 50% increase in the price, and we're going to have a smaller drop in the quantity demanded. So I'll just fill in the diagram here. So we're going to initially be at a price of $2, and then we're going to increase it 50%. So that'll be $3, right? So we're going to go from 2 to 3. And so let's think about what happened. Well, first, let's think about elasticity here. So here we have that the percentage change in the price is larger than the percentage change in the quantity. So here the percentage change in the quantity it drops by 20%. So when we increase the price from 2 to 3, we go from 10,000 to 8,000. Okay, so in this case, since the percentage change in the quantity is less than the percentage change in the price, we say that demand here is inelastic. And when not, in this case here, we're going to first think about what our revenue is initially. So our revenue initially is 2 times 10,000. So it's this rectangle here, F plus G. Now, when we increase the price, we're going to gain $1 per unit that we sell. So on the first 8,000, we're going to gain this area E, but we're going to lose out on this amount of sales, which is area G. Okay, and in this case here, we'll still have an increase in revenue because area E is greater than G. So in the previous case, when we had elastic demand, and we lowered the price, we were able to increase our revenue. If we have inelastic demand and we increase our price, we're able to gain revenue. Okay, so let's look at the more general picture. So actually, I'll move on to this next slide here because this shows you the general picture. So any linear demand curve, right, we're going to have a certain pattern. First of all, the price associated with the center of the demand curve refers to the price that would maximize revenue. Okay, so what are we doing here? So if we look at, say, this point here, at this point here, the price is 9, and the demand curve tells us we'll sell 1 unit. Okay, so what's our total revenue? Well, it's going to be 9 times 1. So below, we're just plotting that revenue. Okay, so here, this point here is 9. Okay, now if the price is $8, we'll be able to sell 2, and so our total revenue is 16. We can look on the other side here. So if we are at a price of $1, we're going to have $9 in total revenue. That's this point here. If we increase the price to $2, our revenue is going to be 16. That'll be this price here. So we can see that if we start here at low prices and start increasing the price, the total revenue starts to increase. Then at the center of the demand curve, any higher prices than the price corresponding to the center here, we start to decrease revenue. So any linear demand curve will have this pattern. Okay, your revenue will first increase and then it will start to decrease. Now, what's interesting here is if you were to calculate, we'll look at that in a moment, but if you were to calculate elasticity along this portion of the demand curve, you will find that it's inelastic, meaning that the percentage change in the quantity relative to the percentage change in price, that will be, the percentage change in the quantity will be less than the percentage change in the price. And then any points up to the left here will be the opposite. It'll be elastic, meaning that the percentage change in the quantity will be greater than the percentage change in the price. So basically, we can summarize what happens when we increase or decrease the price along the elastic or inelastic portion of a demand curve. If we're on the elastic portion of a demand curve and the price increases, and just think about it intuitively, if it's elastic, that means the percentage change in the quantity is going to be quite large. So if we increase the price, then we're probably going to lose a lot of sales. So our revenue will fall. However, the other way around, if we're on the inelastic portion and we lower our price, we're going to gain a lot of sales in terms of the percentage change in quantity. That will more than offset what we'll lose from having a lower price, and so our revenue will increase. If we look at inelastic demand, we just have the opposite results here. So on the inelastic portion of the demand curve, if the price goes up, then the revenue will also increase, because again, the percentage change in this area, so when the demand is inelastic, that percentage change in the quantity will be lower than the percentage change in the price. So we'll be able to get more revenue. And then it'll be the other way around if we decrease the price. So one way to remember this is I just always remember, if you can increase the price, or how it may be better said like this: if you increase the price and revenue increases, then you're on the inelastic portion. And then you can sort of just figure out the rest from that. So if you increase the price and revenue increases, you're on the inelastic portion. Well, if you found that revenue decreased, then you must be on the elastic portion. And then you can just do the same thing for a price fall. So if you're on the inelastic portion and you lower your price, your revenue will fall. And so if you find that the revenue increases, you'll be on the elastic portion. And then the unitary elastic part would just mean there's no change, right? Because at this point, the definition of unit elastic is that the percentage change in the quantity is equal to the percentage change in the price. So let's do a question. So we'll do an active learning question just to reinforce this material. So we're given some demand curve information here. We have the price of canoes and we have the quantity demanded of canoes. Okay, so we go from a price of 800 to 200. So when the price is 800, so that's pretty expensive, the quantity demanded is only 400. If the price is 200, it's much higher at 1600. So, it's our typical downward sloping demand curve. So we're first asked to plot the demand curve. Then we're told to figure out what the revenue is at each of the prices. And then we're going to figure out whether or not the different, what portions of this demand curve are elastic or inelastic or unitary elastic. If we plot this demand schedule, we'll get the demand curve that looks like, this. Okay, so here's the point when the price is 200, here's our quantity demanded. So, this is 200, 1600. This point up here is 800 and 400. And so that's our demand curve. So that was the first part of the question. Now it's asking us to calculate the revenue at each price. So I'll open it up to the chat. So if the price is 800, what will be total revenue without looking at the answer? Yep, good job, Avreet. So we take the price of 800 and multiply it by 400 and we get 320,000. Okay, so if we do that for each of these prices, we'll get this total revenue column. So 600 times 800 is 480,000. 400 times 1200 is 480,000 as well. When the price is 200, we'll sell 1600, so we would get a revenue of 320,000. And so again, we see this pattern of so as we start at low prices going up, we see that revenue increases, it plateaus at some point. So the price in the middle here would be where it's maximized. So like that would be around, so that would be at 500. Okay, so the quantity at 500 is in the middle of 800 and 1200, so that would be 1,000. So it would be $500,000. So we get, this is the similar pattern. This is basically the pattern that I was showing you in the previous slide. where you have this, hump or parabola type figure, and it's maximized at the center of the demand curve. Okay, and again, here the center would be right here, so this is where revenue would be maximized. Now, the next part of the question says, to state whether the market demand for canoes is elastic, inelastic, or unit elastic in the three price ranges, 800 to 600, 600 to 400, and 400 to 200. So all we need to do is just look at how revenue changes and follow that rule of, the rule of thumb I mentioned, or, the slide that we looked at that showed exactly what happened for each of the different section. So let's look at the first range. So if we look at the price going from 800 to 600, total revenue moves in the opposite direction. It goes from 320,000 to 480,000. So again, if the price falls and revenue increases as it does between the price of 800 and 600, we say that this range is elastic, okay? Now, if we look at the range from 600 to 400, we find that total revenue stays constant. So we can say that this range, it's unit elastic, and overall it's unit elastic. And if the price falls even further from 400 to 200, what happens to total revenue? Well, from the previous slide, we know that it will fall. And so it would go from 480,000 to 320,000. So I'm going to go back to that slide, so just so we can see it here. So if we go from 800 to 600, our revenue increases. So if we can, if you drop the price on the elastic portion, you're going to get a lot more sales, so your revenue is going to increase. Here, going from 600 to 400, we actually have no change in revenue. So we're just going to say that range is unitary elastic. And then if we lower the price from 400 to 200, we're going to get more sales, but it's not enough to offset that very large percentage decrease in the price. So we're going to lose revenue. In terms of my rule of thumb, I always like to think of, if I can increase the price and get more revenue, think of being in the shoes of a firm owner. If I can increase the price and get more revenue, then I must be on the inelastic portion of the demand curve. So from 200 to 400, since revenue increases, we're on the inelastic portion. We go from 400 to 600, it doesn't change, so it's unitary elastic. And then if we increase the price by, again, $200 in this range, our revenue falls. So then we must be on the elastic portion. Okay, so here we've delineated the different sections of the demand curve. So elastic, unit elastic, and inelastic. So what are some of the determinants of demand elasticity? So what are some of the reasons for the consumers to be more sensitive to price changes, in some cases rather than other cases? So we can categorize them into sort of four different categories. One is, how much does the price, if you think of the price of a good, what is that price as a portion of a person's income? So bubblegum, the price of bubblegum is a very insignificant portion of someone's income. So everything else constant, changes in price, percentage change in prices there aren't going to have as much of an impact. But if you're thinking of looking for cars or purchasing home or boat or something like that, a 10% difference in the price makes a big difference, especially in terms of how much you're going to spend in total. So the proportion, what the price of that good represents in terms of the proportion of your income is an important determinant. Now, the most important thing is access to substitutes. I think I mentioned in the last lecture at the beginning, when you're thinking of elasticity, if you think of the two terms being able to do without or substitute, those are really the most important determinants. So if you think of a product, if this product is easy to do without and there are many substitutes, well, then the demand for it is, generally going to be elastic, right? But if it's something like electricity, where it's not easy to do without and there are no substitutes, then the demand is elastic. So we're gonna, we're saying, it's inelastic, and so we're saying that for any percentage change in the price, the percentage change in the quantity demanded will be much less. Again, if there are lots of substitutes, consumers will be more responsive or sensitive to price changes, and the other way around. And so this is the concept of being able to do without. So if the good is easy to do without, then usually that's a luxury good, right? It's much easier to do without a luxury good than it is to do without a necessity, like maybe medicine or something like that. Okay, so whether or not the good is a necessity or a luxury is an important determinant. And time is also, also plays a role here. If you think of, just think of someone's demand for something over time, well, over time, consumers can learn about possible substitutes, or they can change their habits and needs and that sort of thing. So over time, you can figure out ways to be less reliant on some type of good. For, if you were to think of a very long time horizon, and thinking of maybe gasoline or oil, right now, the demand in general for gasoline for our cars is very inelastic, right? We have to go to work, we have to drive. It's very difficult for us to do without, and you can't put olive oil in your gas tank. You have to put gasoline. But over time, of course, as a society, we can find new ways of fueling our cars, electric cars, solar cars, things like that. So over time, things can change, or we can just figure out ways of not, we as an individual, maybe we can find an apartment that's right next door to where we work, and then we can do without gasoline because we can just walk to work instead of having to drive. So that's the idea there. And again, this is just sort of a review. Elasticity and a linear demand curve. Along any linear demand curve, we can look at different portions. And if we're thinking of the percentage change, in this portion here that's elastic, so from the center, this range right here, from the center up into where the demand curve hits the vertical axis, that's the elastic portion. So any linear demand curve, if we go along here and calculate the percentage change in the quantity with respect to the percentage change in price, we'll always get that it's greater than 1. And so that the percentage change in the quantity will be greater than the percentage change in the price. And then the opposite is true for any points along the demand curve to the right of the center. Here, you'll always get that the percentage change in the quantity will be less than the percentage change in the price. So we call that elastic. And remember, if you have a very steep, so when we talk about, whether so any demand curve will have portions of that we call inelastic and elastic. But if you remember, if you have a very steep demand curve, we said that, it's an inelastic demand curve, but still there'll be portions on it that are elastic and inelastic. But when you have a very steep demand curve, for any given price change, you're going to have a very small change in quantity. But there we're just looking at the change, not the percentage change. When we're thinking about elasticity along a demand curve, we're thinking about the percentage change. And also, if you were to consider a very steep demand curve, then for any, reasonable prices that you would use, think of a demand curve being very steep here. The inelastic portion will be likely what you'll be, practically considering, because that's, that lower portion below the half will be where it's more likely to be in price ranges that we would think of a normal good. So a linear demand curve has different price elasticity along, at each point. Okay. Again, this is the elastic portion. This is the inelastic portion. And in the center, we just say it's equal to 1 or unitary elastic. So we haven't yet talked about the formula. So now we'll do that. So the general formula for calculating elasticity, in general, there's different types of elasticity. For the price elasticity of demand, all we're doing is looking at a ratio of the percentage change in the quantity demanded over the percentage change in the price. Now, we actually are using the average here. So let me just give you a little background on that. So I'll just go over to the whiteboard here. So suppose we're thinking about the price of a good, and the price today, let's think about, the price today is equal to $3. The price yesterday is equal to $4. If I ask you what's the percentage change in price today versus yesterday, how would we calculate that? Yes, that's right. So a percentage change, I always remember a simple formula. I do new minus old, and then I divide that by old. Okay, so I do new minus old divided by old. Sorry, this isn't the best software to, let me do that again. So new minus old divided by old, and then I multiply this whole thing by 100. Okay, so in the context in this question, what is the new, well, the new price is what it is today. Okay, so it's 3. So we're going to do 3 minus 4, which is equal to -1. And then we're going to divide that by what the old price is, so what it was yesterday, which is 4. So all we're doing with the percentage change is we're looking at the difference, and then the difference as a proportion of what it was before. So in this case, it's going to be equal to 0.25, and we're going to multiply that by 100, and we're going to get 25%. Now, what if I wanted to know the percentage change? I'll just do percent change in the price comparing today or yesterday. So in this case, what's the new price? And do you guys, who thinks that it's going to give you the same answer? Okay, so you actually won't get the same answer. So let's see why. So if we're basically asking how much did the price increase since yesterday? Well, so the new number is, so the price yesterday, so the new number is, yesterday to today. So yesterday it was $4 and today it's $3. Oh, so that's what we did before. So what we're saying now is how much larger was it yesterday compared to today? So now we're doing 4 minus 3 divided by, okay, yep, good. And then we're going to multiply that by 100. And as some of you have mentioned in the chat, we're going to get that it's 33.3%. So when we go from 3 to 4, we're basing that change on where we were before, which was 3. So 1 divided by 3 is 33%. But if we're looking at it the other way, if we're going from 3 to 4, we have that the old number is 3. So we're looking at this difference divided by 3. But if we're looking at going from 4 to 3, then it's the other way around. So we were originally at 4, but now we're down to 3. So that 1 unit change as a proportion of 4 is 25%. Okay, so the key point here is first, I just want to refresh your memory on how to calculate a percentage change, and then second, it depends on what direction you're going. It depends on the context. What's your comparison? Is your comparison, the price before, the price after? It depends on the context, what question you're answering. It doesn't need to be relative to time either. You can, if you had, say the price of a can of Coca-Cola at the convenience store is $2, but at the grocery store it's $1. Well, then percentage difference in the price in the convenience store relative to the grocery store is 100%. It's double, right? But then if you ask the question, how much cheaper is a can of Coke in the grocery store compared to the convenience store? Well, in the convenience store, it's $2. In the grocery store, it's $1. So the price is 50% lower in the grocery store compared to the convenience store. Okay, so again, percentage change is the difference. The difference is always the same. It's going to be 1 in absolute value. And then you're dividing it by either where you were before. Okay, were you at 3 before or 4? It depends on the context. So now this relates to the elasticity, because this is, it's confusing. So if we're talking about the elasticity of demand between two prices, we need to say what direction we're talking about. the general formula for elasticity is simply the percentage change in the quantity over the percentage change in the price. But each time we do those percentage change calculations, it depends on which direction you're going. And so we'll get a different measure of elasticity depending on if we're going, say, from a price of $3 to $4 or $4 to $3. So the solution to that is to divide by the average when you're calculating a percentage change. When I'm doing the percentage change, so I'm going to redo that. So in economics, we use the delta symbol for change. So the percentage change of two different goods. So let's say we'll do X and Y. So X and Y are values. The percentage change just ignore that. And the percentage change, all right, let me type that out. So let me just try that again. So when we calculate the percentage change, in the denominator, we're going to use the average here. And then on the top, we're going to have the change, right? And so if we're thinking of the $3 and $4 price difference that we just talked about in the last example, on the top, we're going to have 1. So the difference is always 1. It could be negative, it could be positive. So we could get negative or positive, okay? But in absolute value, it's always going to be 1. And then on the bottom, instead of dividing by 3 or 4, we're just going to divide by the average. So we're going to divide by 3.5, okay? So when we calculate a percentage change, then we're going to change it a bit. We're not going to care which direction because we're just going to divide by the average of whatever two numbers we're looking at finding the percentage change, okay? So that is actually called the midpoint formula way of doing it. And so that's how we'll do it when we calculate elasticity. Again, so just the elasticity formula or the price elasticity of demand formula in general is the percentage change in the quantity demanded divided by the percentage change in the price of the good, okay? But when we calculate either of these, we're going to use in the numerator for the percentage change the average price and the average quantity. So that's the general formula. Usually we need to know what direction we're talking about and that sort of thing, but we're just going to use this midpoint formula to calculate it, okay? So I'll go back to the lecture slide and hopefully this formula now will make a bit of sense. So the formula for the price elasticity of demand, the change in the quantity demand divided by the average Q. And so this is a proxy for the percentage change, but we're just looking at the average, okay? So won't matter. You'll get the same answer here no matter what direction you're moving in. If the price increases, then this, the change in quantity is going to be negative, okay? But if the price change but remember, it'll be negative up here, but positive here. You'll always get a negative number for the price elasticity of demand. And that's because we have the demand curve is downward sloping. Price and quantity move in the opposite direction. So if price increases, this quantity will fall. If price decreases, this will be negative, but this will be positive. It'll always be negative. So sometimes we just kind of ignore the negative sign. So basically then to calculate the elasticity of demand, you just look at the change or difference in the quantity divided by the average quantity and the difference in the price divided by the average price. Okay, and again, we're always thinking about two different points on the demand curve. Okay, and if you didn't catch that before, this delta symbol is just a short form for change, the change in quantity demanded or the change in price. It's easier to write that than to write out the word change in. Okay, QD stands for quantity demanded. So let's do an example. So we had a case before with a hot dog vendor. This hot dog vendor will sell 500 hot dogs a day if the price is $5 and 1,500 if the price is $3. Okay, so let's calculate the price elasticity of demand between these 2 points on the demand curve. So can anyone tell me in the chat what the change in the quantity demand is? Yep, that's right. So it's 1,000. So we're going to take, so the change in Q is 1,000, and then we're going to divide that by what? What's the number we're going to divide that by? Yep, that's right. We're going to divide it by 1,000 because that's what the average of 500 and 1,500 is. If we take 1,500 add 500, we're going to get 2,000 divided by 2 is 1,000. Now, for the price, what's the change in the price? Going to be 2. And what's the average price? 4, exactly. So we put everything together and calculate it, and we will get that the price elasticity of demand is -2. And again, it doesn't matter which direction. If we said that, we're using the average, so we're not going to have the issue of it mattering which direction we go. And whatever way we go, we're always going to get a negative value. Okay. So the price, so here we're, in terms of words, we're saying here that in this range, the percentage change in the quantity demanded is 2 times more than the percentage change in the price. You could think of just rearranging this and remember, this thing is just representing the percentage change in the quantity. This thing on the bottom is representing the percentage change in price. So if this equals 2, then, and we wanted to find out and we knew what the percentage change in the price was, we could just move this over the other side of the equal sign, right? So it'll be this multiplied by that equals this. So this is equal to 2. So if we had a 10% increase in the price, then 10 times 2 is 20. So we know that the percentage change in the quantity demanded would be 20%. So that's what this 2 is telling us. It's telling us that the percentage change in the quantity demanded is 2 times more than the percentage change in the price. And so we say that because the absolute value here is greater than 1, we say that the demand is elastic. So here is another example. So we have a demand curve. Okay, so we've plotted these 2 columns. We have a demand curve. And then if we were to calculate the price elasticity of demand between the different points, we'll get these numbers here. So at any price range above $3, demand is elastic. Again, $3. Okay, so here it's going to be greater than 1. And where are we getting that from? Well, if we calculate the elasticity between 3 and 4, these probably should be shifted up so they're in the middle of these. So if we looked at the difference between 3 and 4, we would get 2.33. If we look at the difference between 4 and 5, we'll get 9. So this 2.33 would correspond to this, and then the 9 would correspond to this in the middle here. Okay, and then if we go between 2 and 3, well, we know between 2 and 3 here, right in the middle is the center of the demand curve, and that's sort of what delineates it. But if we look at just overall 3 and 2, we're going to get that there's, if we were to calculate this elasticity coefficient, using the midpoint formula, so then we're going to be getting the point in the middle, we're going to get 1, okay? And then if we do anything below that, we're going to get them to be less than 1, okay? So using the midpoint formula, we would see that in between these 2 points, we're going to get the elasticity of demand being equal to 1. And then between here and here, it's going to be greater than 1. And between here and here, it's going to be less than 1. So we'll say that this is the inelastic portion, this is unit elastic, and then this is elastic. So here again is our canoe example. Now it's just asking you to calculate the actual elasticity of demand. So if we were to look at between the price of 800 and 600, so let's just look at how we calculate that. So the quantity change is equal to 200. So we're doing, so actually, sorry, the question's asking for some reason, so this is the price. So 800 and 600, the quantity changes by 400. Okay. So between these 2 prices, the quantity changes by 400. So 800 minus 400 is 400. We divide by the average of these 2 numbers, which is 600. Then in terms of the price, we know that the difference in the price is 200, 600 minus 800, and then we divide that by the average price, which is 700. So when the price goes from, in between here, so if we're thinking of the elasticity at this point right in the middle, we will get that it's negative 2.33. It'll be negative 1 here, and it will be less than 1 here. So here, if we're looking at this portion, the price difference again is 200. So that's this difference here. We divide it by the average, which is 300. For the quantity, the change between these 2 points is 1600 minus 1200. and then we divide by the average of 1,600 and 1,200. And it's just asking, are your answers to part C and D consistent? Why or why not? Yeah, of course they are. If we were to think about remember before we had the revenues, well, remember the revenue, so between here and here, remember the revenue was 320,000, then it went up to 480,000, then 480,000 again, and then 320,000. So again, this is all consistent to what we talked about before. The inelastic portion, if you increase the price, revenue will increase. Along the unitary elastic portion, if you change the price, there'll be no change in revenue. And then above 600, if you increase the price, your revenue will fall. So it goes from 480,000 to 320,000. Okay. A consumer is about to buy 4 shirts at $20 each. When she finds that they're on sale for $17, she buys 5 shirts instead. Is her demand for these shirts elastic or inelastic? How do we answer this question? Yeah, so all we need to do is multiply 4 times 20. When we do that, we get 80. And then so now if the price goes up or if the price goes down to $17, the quantity increases by 1 unit. So, but we can look at the revenue to determine it. We don't need to calculate the coefficient. So here, what's 17 times 5? Anyone? So it's 85. So we get the revenue, or you can think of here the expenditure, going from 80 to 85 when the price increases. So if we have a price increase and revenue increases, which section of the demand curve are we on? Well, here it would be elastic. So when we we're lowering the price. So when we lower the price and the revenue increases, then we're on the elastic portion. Okay. Also, we can just think of the percentage changes in the price. The percentage change in the price is 15%, but the percentage change in the quantity is 25%, right? So if we compare 17 and 20, that percentage change is 15%, and then the percentage change between 4 and 5 is 25%, so we know that it's elastic. Okay, so let's go on to the second part of the elasticity lectures. I'm going to go a little faster this so we can make sure that we get to at least start some of the stuff on costs. So there's just 2 other elasticity concepts. So, okay, so we can also look at the income elasticity of demand and the cross price elasticity of demand. So a lot of this stuff's the same in terms of the calculations, but you just got to be aware of the minor differences. But again, you would always use that midpoint formula where you're using averages. So for income elasticity, in the numerator, we have the quantity demanded of the good again. Okay, so that's the same as what we did before. The only difference is the denominator now is the percentage change in income. So now we're looking at the percentage change in quantity demanded of a good with respect to a percentage change in the consumer's income. Remember, income is another determinant of quantity demanded. It's easy to do an example to illustrate it. So here we have an income change of 20,000. And then as a result of that income change, the quantity demanded went from 1,000 to 2,000. So how do we calculate income elasticity? Okay, so it's just the same thing. So in the numerator, we're going to look at the change in the quantity demanded, which is 1,000. And we're going to divide that by the average of the 2 numbers. So that's 1,500. Now for income, what's the change in income? Well, it's 20,000. We're just going to do 40,000 minus 20,000. Now, it's important to point out here that the sign of this does matter. So we want to make sure we're doing things properly. So on the bottom here, we are looking at an increase in income. So we're taking the 40,000 minus the 20,000. On the top, we're looking at an increase in the quantity demanded. So 2,000 minus 1,000. So in this case, we know it's going to be positive. And then again, we're just dividing by the average of the 2 numbers here. So when we calculate it, so we plug everything in and crunch the numbers, we get that it equals to 1. Now, since it's equal to 1, since it's positive, actually, we're going to say that this is a normal good. So because normally we think that if your income goes up, you would want to buy more. But that's not always true. If we're talking about an inferior good, then the quantity demanded would fall. So if this turns out to be negative, we would have an inferior good. If it's positive, it's a normal good. And so this next table here summarizes, I'll just set that up again, so I didn't realize it wasn't in full screen mode. So this summarizes the different things that could happen with income elasticity. If you get a coefficient greater than 1, we say it's a normal good. And since if it's greater than 1, then the quantity percentage change in quantity is fairly large relative to the percentage change in the income. So we say it's more of a luxury good. But if it's between 0 and 1, then we'll say it's a necessity. So, something maybe like bread, if your income doubles, you might buy a little bit more bread, but, you're not going to buy that much more. But if your income doubles, you might buy more, luxury good. The change in how much you would purchase of a luxury good might be a lot more. And again, if it's negative, it's an inferior good. Actually, don't worry. You can skip this slide. Don't worry about this. Now, cross-price elasticity is when we're looking at the quantity, we're looking at the responsiveness in the quantity demanded of a good relative to the price of a related good. So again, remember, the quantity demanded of a good is a function of the price of the good. That's the most important. That's what we put on the demand curve diagram. But other things like income are important. We just looked at that. But the price of related goods is also important. So here, in terms of the cross-price elasticity of demand, the numerator, again, is the percentage change in the quantity demanded. But now it's with respect to the price of another good, not the price of the good itself. So again, an example is the best way to illustrate this. So suppose there's a drop in the price of computer tablets from 1,000 to 500, and then this causes the quantity demanded of laptop computers to fall from 5,000 to 3,000. So how do we calculate the cross-price elasticity of demand? Well, in the numerator, we're going to plug in our numbers for the quantity demanded, which was, so we had here it changing from 5,000 to 3,000. Okay, so the difference here is going to be 2,000, but we're saying it's going to fall from 5,000 to 3,000. So this is, it's going to be negative 2,000. Okay, and then we're going to divide that by just the average here, which would be 4,000. And then what happened to the price? Well, the price fell, so there was a drop in the price. So it's now 500, but it was 1,000 before. So this is going to be negative as well. And then we divide that by the average. And so what we end up with is a positive number equal to 0.75. So if the percentage change in the price, so in this case, we have a fall in the price. So here the percentage change is negative. If that leads to also a negative percentage change in the quantity demanded, then the two goods must be substitutes. Remember, think of my example in the mall where you have two pizzerias. If one of the pizzerias lowers their price, what happens to the quantity demanded of the other pizzeria? Well, their quantity demanded would fall, right? So these things work in the same direction. If they work in the same direction, we're talking about a substitute. If they work in the opposite direction, we're talking about a complement good. Okay, so if we had a complement good and we were given an example, the coefficient that we would calculate would be negative, right? Because we would have the percentage change in, say, so think of hot dogs and hot dog buns. If there's a increase in the price of hot dogs, so the percentage change in the price is positive, then that would likely result in people buying less hot dog buns. And so we would have that the percentage change in the quantity demanded of hot dog buns would be negative. So we would have the net effect, the net would be, it would net out, we would be left with a negative number. And then if we're getting something that's close to zero, then it's likely the goods aren't related at all. Like there'd be no reason to expect that a percentage change in the price of house paint would have any effect on the quantity demanded of hamburgers. Okay, so again, if it's positive, they're substitutes, negative, complement. Again, we can just skip these diagrams here. So price elasticity of supply. So now we're talking about the quantity supplied. So now we're thinking of the firm, and we're thinking of the firm's ability or willingness to offer goods for sale, right? So now we're thinking of their responsiveness in terms of their ability to offer or their willingness to offer goods for sale. So here we're thinking, you could think about the N95 masks. So in a very short period of time, the demand for them increased a lot. So they could get a much higher price. Now, were they able to immediately meet that higher demand? Because remember, a supply curve traces out the relationship between price and quantity supplied. So the higher the price, the higher the quantity supplied. So in terms of elasticity, if there was a very quick and an immediate response, so that the percentage change in the quantity supplied is very large relative to the percentage change in the price, then we say that the supply is elastic. If the supply is fixed, because it's very difficult to produce more, then we say that the supply is inelastic. So okay, I don't know why we don't have the formula here. Let me just make sure. Okay, so anyways, the formula might be listed later, but it's going to be the same thing, but just with quantity supplied. So the price elasticity of supply is just going to be equal to the percentage change in the quantity supplied divided by the percentage change in the price. So elastic supply would mean that the percentage change in the quantity supplied is greater than the change in the price, and the inelastic supply would mean that the percentage change in the quantity supplied is less than the percentage change in price. So if we were to have a supply curve like this, for this $1 increase in the price, the quantity supplied would double. Okay, so that's quite elastic, right? Here, the percentage change in the quantity is 100%. The percentage change in the price is 50%. But if there's many obstacles in terms of offering more for sale, maybe it's very difficult to produce more, especially when you're thinking of a short period of time, you could have the case where for that same increase in price, the percentage change in the quantity is very small. In this case, the percentage change here is 20%, but the price increase is 50%. So this is an illustration of where we would say there's inelastic supply. So time is a real important issue when we're thinking of the elasticity of supply, because as more time passes, the firms are able to overcome any obstacles that are in their way of being able to offer more for sale. So just a quick question, just in general, what do you think would have more inelastic supply and why? The supply of paper clips or the supply of new housing? Anyone? That's right. So new homes, because it takes a long time. You have to get permits. They have to plan. It probably takes a year or more just to get the plans ready before you even put a shovel in the ground to start building them. Whereas a paperclip factory could maybe just buy another machine quickly, or maybe run the factory 24 hours and double their production easily. So there's much more obstacles in terms of new housing. So then at the same time, let's think about what would happen if demand for either of these two increased. So in that case, if demand increased by a lot, which one would you expect to see a larger or sharper increase in the price? That's right. So because basically we're saying in the short run, the supply is basically fixed for new homes. So if there's an increase in demand, you're just going to get prices being bid up. I'll let you do these ones for homework. And so you can have you could draw a perfectly vertical supply curve. And what would that mean? Well, that would mean that the supply is fixed. And we could think of the, very, very short term, this would tend to be true. If we think of a farmer's market, the farmer fills up their truck to go to the farmer's market. That particular day, the supply that what they can offer for sale is fixed. It's whatever they brought with them in the truck. They can't offer any more for sale in the face of higher demand. And so the price then would just get bid up and the price would get a lot more if instead, a lot of the farmers at the market could supply more that day given an increase in the price. We could also draw a supply curve that's perfectly elastic. Okay, so perfectly elastic means that it's as sensitive as it can get. So it would mean that an increase in demand can be met without any change in price, so that the supply curve is horizontal. So these are just two extremes. We looked at extremes of demand as well. So again, as I said, the time dimension is important here. So we can think of basically we can think of the short run, or maybe even like the market period, that day or something like that. That's very short. The supply is going to be more inelastic the less the time period. So in the short run, you're sort of limited by the size of the plant, the number of workers, your plant size. So you can only do so much to increase your how much you offer for sale. If you think of a pizzeria, they're probably running almost at full capacity. They could do some small things here and there, like maybe find room for another oven to increase. Think about a business doubling their production. Is it easy or not? So some businesses they can do it in a quicker time period than others. But in the long run, in principle, you should be able to increase as much as you want, because you can overcome any obstacles. You could buy a bigger building or plant, or restaurant size for your pizzeria, etc. So basically, we can think of in the immediate run, or that day or market period, the supply curve is, we would represent that with a vertical, perfectly inelastic supply curve, because the quantity is fixed. But as time passes, it will be more elastic. Okay, now again, if we're thinking of the long term, so when we're thinking of, the idea of a constant cost industry is that, so suppose there's a higher price of strawberries, that raises production, but it doesn't affect resource prices. Well, if that's the case, new businesses will enter the industry and drive that price rate back down again. So we can think of the long run supply curve for a constant cost industry as being perfectly elastic. So the idea, I'm not sure if there's not a diagram here, but you can just think of, okay, you have a market, the demand curve shifts to the right. That's going to cause the price to increase, right? If that attracts more firms to this industry and more is offered for sale, that's going to drive the price back down again. And if there's no issues with resource prices being pushed up as a result of that bigger industry, then in the long run, the price shouldn't change all that. This shouldn't change. So we would represent that with a horizontal supply curve. If there's an increasing cost industry, then that, suppose that the higher price of strawberry raises, that's going to raise production. There are going to be more firms interested in selling them because they can make money. But that could drive up, say, the price of fertilizer or something like that. So then, the price is not going to get pushed down to the price it was before, because, the costs are a bit higher now. Because if it went down further, it went down to the same as before, there would be people losing money and leaving the industry. We'll get into this a little more too when we talk about costs. So this is kind of jumping the gun a little bit, this chapter. So the long run supply curve for an increasing cost industry would be very elastic. So we would think of it as upward sloping, but not very steep. Okay, and then a decreasing cost industry would just be downward sloping. Oh yeah, so here's the calculation of the elasticity of supply. Nothing, I'm not going to spend too much time. It's the same thing, except you have quantity supplied here in the numerator. And you would calculate it in a similar manner as before. You have the percentage change in the quantity and the numerator, percentage change in the price. And you should always get a positive number for this because the supply curve is upward sloping.